Hi there, my name is Miss Townsend and I love math. This video is for grade 11 students in functions and relations who are working on the year-end summative, and this is question number 1 from that summative package. Here's the question. The sticker warehouse sells rolls of stickers for $4 each. The average customer buys 6 rolls of stickers. The owner finds that for every 25-cent decrease in price, the average customer buys an additional roll. The revenue per customer is, and here they give us an equation, uh, so there's the equation. And in this equation, x is the number of 25-cent decreases in price. And here's the math we have to do. What is the maximum possible revenue per customer? How many rolls of sticker and at what price? And how many price reductions will the revenue per customer be $30? Okay, so let's look carefully at this equation in great detail before we try to do the math. It's important that we understand where this equation comes from. So it's revenue, and we know that revenue is a calculation where we multiply something like the price of each object times the number sold. So if I'm selling lemonade and it's $2 per cup and I sell 30 cups, my revenue would be 60 bucks. That's what revenue is. So here we have an equation for revenue where we have this forward minus 0.25x multiplied by 6 plus x. So one of these brackets must represent the price, and one of them must represent the number sold. So here's what I know about the price of the object, the price of the stickers. We know that originally the price is $4 each, and here I can see that original price. But then we're going to change the price by 25 cents every time we do one of these decreases. So every time we decrease the price by 25 cents, the price goes down. So this represents the fact that I'm going to decrease the price. So subtract is decrease the price by 25 cents, but I'm not sure how many times I want to do that price decrease yet. So this is all the price after I decrease the price by a certain number of times. Then, of course, we also have information about the number of objects sold. So when I look at the number of objects sold, we know that originally they're going to buy 6 rolls. So here's the original number sold, which is 6. But then we're also told that every time that they do this x, every time they decrease the price, the customer buys 1 additional roll. So every time I do x by decreasing the price by 25 cents, I have to increase the number sold by 1. So every x is 1 in the number sold. So that's where this equation comes from. And our goal is to maximize this equation. So what you should notice about this equation is that if I were to algebraically multiply this bracket, the price bracket, times the number sold bracket, at some point I would multiply this term times this term. And if I were to multiply those together, I would get a term with x squared in it. And that means that I know that this is a quadratic equation. So I know that this revenue equation is a quadratic, and what I'm asked to do, if I go back to the beginning here, what I'm asked to do is to find the maximum possible revenue. And I know that if I need to find the maximum of a quadratic, then what I really need to do is to find the vertex. So that's going to be our goal, is to find the vertex of the quadratic equation represented here by this revenue equation. So how do we find the vertex of a quadratic? There's a couple methods you've learned in grade 10 and this year. One method is to complete the square. So if I had an expression that looked like this, so it's in standard form, then one option I might do is to complete the square, because completing the square would turn it into vertex form, and then I could tell you the vertex directly. Another option would be to also, if I was given this form, I could use the quadratic equation to find the roots. Because if I have the roots, then I can find the midpoint of the roots, and then use the midpoint to find the axis of symmetry, and use the axis of symmetry to tell me my vertex. So if I have the roots of the equation, then there's this nice take the roots, midpoint them, axis of symmetry, vertex path I can take. So I could use the quadratic equation to do this. Or another option for finding the roots is to factor the equation. So again, my options are I could complete the square, but it needs to look like this first. I could use the quadratic equation, but it needs to look like this first. Or I could use the concept of factoring to find the roots directly. Now, when I look at this equation, it's already factored. So I'm not going to rewrite it and then do some other process. Because it's already factored, I'm going to find the roots by factored form. So this is factored form, so I'm going to find the roots. And again, we know that the roots are the same thing as the y-intercepts. So I let y, or in this case, revenue, equals 0. And then it's already nicely factored for me. So either this first bracket, oops, not what I meant to do. Either this first bracket is equal to 0, and that gives me one root, or the second bracket is equal to 0, and that gives me the other. So let's do the math for both possible roots. So one of them comes from the first bracket, so solving for x. Negative 0.25, I'll add that to the other side, and then divide both sides by 0.25, and that gives me 16. Here, another possible root comes from this other factored expression, and here I get that x equals negative 6. So my roots are negative 6 and 16. So that means that if I did this price change 16 times, I would have 0 revenue. If I did this price change negative 6 times, I would have 0 revenue. And again, doing this price change negative 6 times would actually mean going up in price. So now I have my roots, and again, our goal was to find the vertex. So I need to find the midpoint of my roots, because that'll tell me where the axis of symmetry is. So I'll just take my roots and add them together, divide by 2. So the midpoint of the roots is 10 divided by 2 is 5. So I know that my axis of symmetry for this quadratic is the line where x equals 5. And that's important because the axis of symmetry, let me just draw any old parabola. Oh, that's not so great. The axis of symmetry always passes through the vertex. So I know that my vertex is at a point where x is equal to 5. I don't know the y value, or in this case, the revenue value, but I know that if x equals 5, I have my vertex. So I'm going to go and take the original equation again. So here it is. Let's see if I can grab it using technology. Woo! And now that we know that x equals 5 is the optimized number of price changes, now we know that we can just sub 5 in for x to this equation, and we'll have our maximum revenue because we'll have found our vertex. So I need the revenue at 5 price changes. So I'm just substituting 5 in everywhere that I see it in the equation. So the revenue at 5 price changes, so the new price would be there. It looks like I'm going to be selling 11 products, and the new price is 4 minus $1.25. So the new price is $2.75. I'm going to sell 11 products at that new price. And when I do the math, that means my new revenue is, multiplying them together, $30.25. So my max revenue is $30.25, because that's the vertex, the output of the vertex of that quadratic. Okay, so what's the next thing? The next thing says how many rolls of stickers and at what price? Oh, so I've already done the math on this. We know that the max revenue occurs when x equals 5. And what we discovered, if we go back to that last screen, is that we need this many stickers. That's 11. And the price would be $2.75. So Number of rolls of stickers, and I'll just show the math again here. So that would be 4 plus x. Nope, hold on. Just confused myself a little. 6 plus x. Yeah, it didn't seem right. That would be 6 plus x. Oop, erase. The number of rolls of stickers was originally 6, but 1 for every price change. So if we're doing 5 price changes, there are now 11 rolls of stickers on average per customer. And the price was $4, but every price change reduced the price by 25 cents. So if we do 5 price changes, that means we have to reduce the price by $1.25. So the new price is $2.75. So at a price of $2.75, the average customer will buy 11 stickers, and that will maximize their revenue per customer of that $30.75 number we had before. And then finally, it says how many price reductions will the revenue per customer be $30? So this is not about maximizing anything. This is basically saying what is X? So how many price reductions is saying what is X if the revenue per customer is $30. So for us, that's saying that the output or the revenue would be 30. So I need to set the revenue to 30 and then try to solve for x in this equation. Oops, wrote that wrong. Sorry, if I knew better how to edit videos, I wouldn't have so many oops in them. So again, what I have here is a quadratic equation, and I have to solve for it. So I'm going to expand and do FOIL, multiply these binomials together. So 4 times 6, 4 times x, negative 0.25 times 6, and negative 0.25x times x squared. And then move everything to the right-hand side. So I'll have 24 take away 30, and then positive 4x minus 1.5x, and negative 0.25x squared. So my next step, I'm going to collect like terms here. I'm going to collect like terms here. And I'm going to order things into an order that's more traditional, which is to put the highest degree term first. So it looks more like a quadratic. So I have negative 0.25x, and then 4x minus 1.5x is positive 2.5x. 24 take away 30 is negative 6. So now I just have to solve for x. So how do I solve for x in a quadratic? Well, there's lots of options. There's some options. But because of the decimals and it doesn't look fun to factor it, I'm just going to use the quadratic equation. So the quadratic equation is that the roots can be found by doing negative b plus or minus the square root of b squared minus 4ac, and all of this is divided by 2a. So if you've never had me as a teacher, you may be wondering what I'm doing. Whenever I have a significantly large equation to substitute into, I always write the equation like this, with blanks for the things that I'm going to substitute in, and then I'll go back and fill in the blanks. It just helps me keep track, and that way I'm not copying the wrong number into the wrong spot, and it also makes sure that I'm not being lazy and forgetting to substitute with brackets. So this was negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So there's the equation. Now I just have to calculate it. So remembering rules of order of operations. So on the top of the fraction, negative 2.5 plus or minus square root of. So I'm a big fan of sort of doing this all at once in your calculator. If your calculator has brackets, do it. Just make sure that you know how to use your calculator properly. So when I do this, I get 0.25, and then the bottom would be negative 0.5. So at this point, I'll separate into my two possible roots, one of which is negative 2.5 plus the square root of 0.25, which is 0.5. And the other one is x equals negative 2.5 minus the square root, which was this. and then just calculating both of these separately, I get one answer. So over here, I get that x equals 4. Is that right? Negative 2 plus 0.5 is negative 2. Yep. And over here, I get x equals 6. So the question was, how many price reductions will the revenue per customer be $30? So there's two answers. At 4 or 6 price reductions, the revenue is $30. Okay, I hope that was helpful, and I'll see you at the next question.